Welcome to this video lecture. This is Dinesh, Assistant Professor in EC Department, Government College of Engineering, Tanjavur. We are in Unit 4, Transport Layer. Today's topic is Introduction to Transport Layer. So these are the concepts we are going to cover today. Starts with Transport Layer, Introduction to Transport Layer, and the functions, segmentations, services. So these are the topics we are going to discuss in this video session. First of all, what is called transport layer? The transport layer is the fourth layer from the top of OSI model, Open System Interconnection. Transport layer is the heart of Open System Interconnection model, and it talks about reliability of communication between two hosts. It talks about process-to-process communication. It deals with logical linking between one specific application in a user device into destination user device, like application to application, process to process communication. And it decides what type of data transmission will occur, whether it is a parallel or a serial data transmission, and it will done multiplexing, demultiplexing, and it provides services to the application layer and receives from the network layer. And see, this particular transport layer, we talk about that data in the form of segment. The data is divided into segments, and that segments will be have a port number, sequence number, and all the things will be present, and that will be passed over to network layer. So this is a major function of the transport layer, and it has several duties to do, and it gives reliability to the communication, and segmentation, flow control, error control. So the logical connection will be given both the end of application layer. It finds the specific application in your host device as well as the destination device. And the main role of the transport layer is to provide the communication services directly to the application process running on different hosts. The transport layer provides a logical communication between application process running on different hosts. Although the application process on different hosts are not physically connected, it's very important. As I said, it is logically connected. And the transport layer have a end-to-end system, in the sense they have a lot of protocols that are available. We have TCP, a transmission control protocol, UDP, user datagram protocol, or user defined protocol will be used in the transport layer. And a computer network provides more than one protocol to the network applications. That will have, we have three types of protocols used in TCP. All transport layer protocols provide, and it has to do multiplexing and demultiplexing, and it has to be given a reliable data transfer, because we have a connection oriented services, connection less services. If you talk about TCP, it is connection oriented service, whereas UDP is connection less service. So the reliability comes from the protocol TCP, and UDP is much faster than TCP. So the delay and bandwidth, so this thing will be deal with transport layer. Each of the applications in the application layer has ability to send a message by using TCP or UDP. We have a huge difference between IP versus transport layer protocols. So they concentrated on hardware part. They are concentrated on a user device part. We are concentrated on application part, the process part. That's very important. And both TCP as well as UDP will communicate the internet protocol in the internet layer. The application can read and write to do the transport layer. Therefore, we can say that communication is a two-way process in transport layer. What's the position of transport layer in OSI model? As I said, it's a fourth layer, and it has to be respond to the session layer as well as the network layer. The network layer is converted into the segments into packet. So it has to do some packetizing and addressing in connections and the reliability. This will be given in the transport layer. We will talk about host to host part of linking. So there it's very much supported, not like other protocol. As I said, it is a heart of your open system interconnection. So what's the function of the function of transport layer. So the basic function, as I said earlier, the basic function of the transport layer is to accept the data from the layer above and split the data into smaller units and pass their data units into network layer. So that's the basic function it has to do, and it delivers a message from specific process. We need to identify the specific process in one computer and the specific process into another computer, as they're saying source part, the destination part. The transport layer adds port address. That's very important. The and other layers are not care about the port address. The port address is used to find the specific application, which type of application well, we are going to use in the source as well as destination. We need to send the data, the proper application. So it depends upon what type of communication or what type of application we are used in the source device. It may be a WhatsApp or it may be a mail, or it depends. It depends upon the application. We need to pick the correct application the user send to source to destination area. It divides the message into smaller segments that we have we'll see in the segmentation part. So each segment contains sequence number along with port address. It ensures that segments arrive correctly at the receiver end and then reassemble them. So if you check out this particular diagram there, they have application layers are all they will be present here. So multiple users are there. They will connect it to the transport layer protocols. We have a streaming control protocol and we have a transmission control protocol, UDP. So something will be reliable. Some is, this UDP is not reliable compared to TCP, and it depends upon the application. If it is a video streaming, we need a fast data rate. So that will be given in UDP. So that will communicate to the IP, next part of the network layer. And the other important thing is it provides an error-free point-to-point channel for both connectionless as well as connection-oriented services. The connection setup is different, like handshaking. We have to give a request and getting acknowledged and sending reports. If it is connectionless, nothing will be happening. There is no feedbacks will be given in that particular service. And it's very important thing. It is isolates that upper layer from the inevitable changes in the hardware technology. It's very much isolated. That's very much useful for not disturbing the hardware technology. And it identifies errors like damaged packets, lost packets, and duplication of packets. That will be done in that duty error control techniques. This is the part of segmentation. As I said, we are getting a data from the session point of view, because we have layers like application, presentation, and the session layer. The next will be the transport layer. The session layer gives the data, that the data will be divided into smaller units. That smaller units is named as segments. Each segment has to be given a sequence number, port number, and data unit. These numbers or this port numbers used to identify the proper. If this particular diagram that talks about this WhatsApp application, this is about the Firefox web browser, and it talks about Google Chrome browser. We need to identify the specific application given in the port number. The sequence numbers used to reassemble the packet or reassemble that segment or data unit to give a correct user, and the correct data delivery will be happening. See this particular diagram, we have a data and that will be divided into segments, and each segments give a sequence number, and we are using the sequence number, we will reassemble and arrange that in proper order and send them to proper application or the proper process. So that's why I say that it is a process to process communication. So what are the services provided by the transport layer? We discuss end-to-end delivery, addressing, packetizing, reliable delivery, flow control, multiplexing. So these things will happen in a transport layer. The service provided by the transport layer are similar to those of data link layer. The data link layer provides the services within a single network, while the transport layer provides the services across an inter-network made up of many protocols. The data link layer controls the physical layer, while the transport layer controls all the lower layers. That's very key point in the transport layer. What is end-to-end delivery? As I said, it talks about specific application present in source as well as destination. The transport layer transmits the entire message to the destination. Therefore, it ensures that end-to-end delivery, so of an entire message from source to destination. Transport layer provides a reliability. That's the reliability of the communication is the major part of transport layer. That will be divided in that they have a lot of reliable delivery sessions. Error control, sequence control, loss control, duplication control. This thing will be happen That's why it is very reliable communication compared to the layers. What is error control? So if we talk about this particular computer versus mobile communication, where we send the data units like this, data unit and data unit 2. Once we send that, some of the, for example, if we see that data unit 2 is missed out, but here it is given, but if it is missed, we need to use that automatic repeat request and resend that particular data unit is possible through error control mechanism. And if any files are corrupted, any data is corrupted, we use the checksum method to find the corrupt file and resend that particular data unit. This is possible in the error control unit. The primary role of reliability is error control. That is the major. Debugging is very important. In reality, there no transmission will be the 100% error-free delivery. Therefore, the transport layer provides a designated to provide error-free transmission. We discussed about the data link layer too. They discussed about node to node error free. We talk about host to host, and the transport layer performs checking for the errors end to end, ensure the packet arrived correctly or not. We already discussed about the sequence control, the second aspect of reliability, which is implemented in the transport layer. And the sending end, the transport layer is responsible for ensuring that the packets received from the upper layer can be used by the lower layer. So that is very important. And that receiving end, it ensures the various segments of the transmission can be correctly reassembled. So that's why we given in the data unit, we will given sequence number. Through that number only we can arrange properly. The loss control is the third aspect of reliability. The transport layer ensures that all the fragments of a transmission arrive at the destination, not some of them. And the sending end, all the fragments of the transmission are given sequence number by a transport layer. So the same thing what we discussed about the previous point. Duplication control is the fourth aspect of reliability. The transport layer guarantees that no duplicate data arrive at the destination. So we have a port number, sequence number. So through these things, we will achieve these to identify the last packet and a duplicate packet. It allows the receiver to identify and discard the duplicate segments. Right, I mean, this is a flexible layer, the transport layer, and we too done that same things in the data linker too, but they talks about router to router or network area, where it talks about the user part, I mean, device part, the host to host part. End-to-end communication, it deals with logic. And the flow control is very important. If you take this particular diagram, see the computer, you have a data rate of 100 Mbps, whereas if it is a server, it has 100 Mbps, whereas your mobile, it will have 10 Mbps. So in flow rate, what we are doing is depends upon that user or depends upon the mobile data rate. We need to cope up with that server. So server, we have to be not given at directly the 40 or 50 Mbps to the user. So because it is not adapt. I mean, this particular mobile will not adapting the data rate what we are given the server. So he in that particular mobile user has to give a request to the server. So my particular data rate is 10 Mbps. Then that particular server provides the data rate for the particular range. So that is the data rate will be controlled through the giving request, and that will be happen in the transport layer. So whatever data rate is possible in the user side, so that will be given to server. That will be very much useful in uploading part as well as downloading part. The flow control is used to prevent the sender from overwhelming the receiver. If the receiver is overloaded with too much data, then the receiver discards the packet. That is happening because if you not adapt to taking the data packets regularly, it will be lost. So that's, I mean, we need to send the packet again, or we need to check that flow control will have to happen. Then only the data will come the normal data rate. This increases the network congestion, thus reducing the system performance. So without flow control, the congestion is happening and the window will, the buffer will be filled and the data rate will be getting higher. So because of that, we can lose some of the packets. We can misarrange. I mean, we need to rearrange some of the packets. That will be happen in the destination area, destination part. We do multiplexing is happening in that transport layer. It's very important duty. We do upward multiplexing and downward multiplexing. The first diagram talks about upward multiplexing. The multiple transport layers. We have multiple transport layers. Our connections use the same network, same networking, and this will happen. We need to use multiplexing. We need to add 3 layers and do the single line. So that is nothing but upward multiplexing. So whereas your downward multiplexing split a congestion among several path. See, we need to split the path to provide the data path in multiple ways. So that will increase your throughput. The transmission efficiency will be very good when you're doing multiplexing, as well as demultiplexing will be happen. So you can get multiple data into single line, and the single data will have to split into multiple lines. It's also possible in the transport layer. We do addressing in this particular transport layer, provides the user address which is specified by the station. I mean, they're talking about port address. The port variable represent the particular TS user of the specified station, known as transport service. What type of transport you using, I mean, the application. Each station has only one transport entity. The transport layer protocols need to know which upper layer protocol. That's the end of this particular video session. And we just started the transport layer of OSI model. And in the coming session, we need to talk about the transport layer protocols like TCP, and the services, features, and the applications, the packet size. I mean, the datagram packets, what type of size they have. So that will be we will discuss in the next video session. This particular video, we discuss about what is called transport layer, what is a function. As I said, it's accepting the data from the session layer and pass over to network layer through segments, small packets, and it gives a reliable communication, and it talks about specific application present in the device. So as well as in the source side, destination, it has to connect. End-to-end connection will be applicable in this particular layer. And one more thing, this is heart, that this particular transport layer is a very core and very heart of your overall OSI model. That's very important. Thank you.